Alright, welcome back. In this particular video, we're going to talk about the box plot and the 5-number summary. Alright, so let's get started. Now, if you take the box plot, we can see that it actually consists of the box, right? So from this part all the way to this part, right? So this is the box part. Right, this is the box plot. Then it's also having a whisker here, right? That's this part, right? Either on the left or on the right, right? So this, the box plot, having the box here, right? This is the box, having the box, and then having the whiskers, right? So let's consider, let's now relate this box plot to the 5-number summary, right? So the lowest value in your data set is actually going to be placed here, right? And then the highest value is actually going to be represented over here, right? And the number in the middle, that's the median, is actually being represented over here, right? And we also have the lower quartile, and then we have the upper quartile, right? So this is nothing but the Q3, right? And then the Q1. Right, the median is also known as the Q2. Okay, so we have the maximum here, then we have the minimum here. Okay, so this is the 5-number summary. We have 1, 2, 3, 4, 5, right? So the numbers that you're going to have to represent this is the minimum number, the Q1 number, the Q2 number, the Q3 number, the maximum number is what we refer to as the 5-number summary, right? So as you work along, right, as we proceed to the project, right? So if you have a question where you've been asked to find a 5-number summary, then this is what we are referring to, right? The minimum, the Q1, the Q2, the Q3, and then the maximum. Okay, that's what we are actually referring to. Now we're going to see some relevance of the box plot and why I added the box plot to some of the statistical concepts that you need to actually get to know before we start the machine learning class, right? So we're going to see some significance of this box plot soon. All right, so the box plot is actually a visual representation of your data set, right? So you're going to see how we're going to use this box plot to see the spread of our data set. Okay, one important concept that we're going to actually use this box plot for is the concept of what? Interquartile range, right? The concept of interquartile range. You're going to see how we're going to use this interquartile range to actually spot outliers in our data set, right? We will talk about outliers, what outliers are, and how we're going to remove them using the concept of a box plot. Okay, so that's what you're actually going to see as we progress in the course. You're going to actually see how we're going to do this. All right, so before we even talk about normal distribution, now let's first make it clear over here that the box plot can actually be used to represent the same skewness that we use the normal distribution to do, right? Whether it is right skewed or it is left skewed or it is symmetric, right? We can use the box plot to represent the same concept, right? We can use it to represent the same concept. We're going to see normal distribution in a while to come, and you're going to actually understand this left skew, right skew, and then the symmetric, right? We're going to actually talk about that. Before we do that, now you can see that we have the Q1, the Q2, and the Q3 over here, right? So we can use the box plot to actually represent the same skewness. And when we get to the normal distribution, tutorial, you're actually going to understand the skewness and how we are going to relate that to the box plot. All right, and we're going to also go to the notebook, the Jupyter notebook, and then get hands-on experience of understanding of this box plot and the skewness that we can use this to actually represent, specifically removing outliers in our data set. Okay, so we can actually use the box plot for the same concept that we use the normal distribution to do. All right, so when we get to the lab session, you're actually going to understand this concept better. All right, so let's talk about these Q1, the Q2, and then the Q3 further, right? So these are the quartiles, right? These are the quartiles. We have the first quartile, the second quartile, and then the third quartile, right? So let's talk about that further. So as we pointed out in the last video, we have the box, then we have the whisker, right? So we have the whisker, which consists of the Q1, right? Then the median here, which is the same thing as the Q2. Then we have the Q3 over here, right? Then we have our maximum, right? We have the maximum here, then we have the minimum. Okay, so these are the quartiles, the Q1, the Q2, and the Q3. And we're going to take them and then get to understand what these quartiles are and how we actually going to use it, or the relevance of these quartiles in our machine learning class. Okay, so let's proceed to the next slide and then see interpretation of these quartiles. All right. All right, so now we will talk about the quartiles, right? The quartiles is actually dividing your data set into 4 segments, right? Dividing your data set into 4 segments. So basically that is the quartile, dividing your data set into 4 segments. Now, if you can see over here, right? So we have your data set to be of a total of 100%, right? So we divide this 100% into 4 segments, which is 25%, another 25%, another 25%, right? Another 25%. Okay, so this is actually going to comprise the if you put all these together, it's actually going to comprise the total data set that you have, which is 100%. Okay, now if you come here, if you pick the Q1, right, the Q1 is saying that it is, the value for it, for which 25% of the observation, right, the value for which 25% of the observation are smaller, and then 75% of the observation are larger, right? So you can see that we have this part, which is, this is the Q1 over here, right? So you see that we have only 25% of the data set to be smaller, right, than the Q1. And then if you take it from here, right, all the way here, this comprises now of the 75%, right? So over here will be 75%. Okay, so you can see that we have 75% of the data points greater than the Q1, and then we have 25% of the data points less than Q1. So if we take this one to be, say, the score of a general test, for instance, maybe GMAT or GRE, right, then you can, or maybe TOEFL, right, you can actually, if you take such a standardized examination, and then your results comes, and then it is reported that, okay, you are at the Q1%, right? Or if you take it just to be, say, percentile, or you take it to be quartile, right? You are the Q1 quartile, right? Then it means that you did better than only 25%, but 75% of the people who took the same test did better than you, right? 75% of the people who took the same test did better than you, right? You can relate this to also, you can relate this to percentile, right? You can also relate this to percentile. Now, over here, what is saying that you did better than 25% of the people, right? Or you are the Q1 quartile, right? Which means is that 25%, only 25% of the data points are below your marks, and 75% of the marks are above yours. Okay. Now, in the same way, if you take, say, the Q2, if you take the Q2 is nothing but the median, right? Q2 is the same thing as the median, right? Meaning that you have 50% of the marks at your, less than you, and then you also have 50% of the marks greater than you. So you are somewhere in the middle, right? You are at the middle of the data points. All right. Now, if you take, say, Q3, if you take Q3, then what is Q3 is actually saying is that you have only 25% of the data points above your marks, but you did better than 75%, right? So all these comprises of 75%. Okay, so you see that, okay, you are at the Q3, so your marks is actually greater than 75%, right? That's the data point that you have. It's actually greater than 75% of the total marks that you have, and only 25% of the data points are above that particular data point that you have at Q3. Okay, so I hope this actually gives you an intuition of what these Q1, Q2, and then the Q3 is. All right. Okay, so now that we have an idea about what the Q1, the Q2, and the Q3 are, right, let's now move on and then relate this to the interquartile range, and then see how we use this interquartile range in our machine learning project. Okay, so over here, you can see that I have this simple code snippet over here, and what this is actually showing you is how we use the interquartile range to actually remove outliers, right? So mostly that's what you're going to encounter. You're going to see this interquartile range in action most of the time, right? You're going to see it in action most of the time, where you have an outlier in your data set, or so many outliers, and you want to remove them, right? So what comes in, there are several methods that you can actually use to remove the outliers, but what actually comes in handy when you talk about outliers and you want to remove outliers is what is referred to as the interquartile range. Interquartile range is nothing but the Q3, right, minus the Q1. Okay, the Q3 minus the Q1. So that's actually the interquartile range, right? That's actually the interquartile range. Okay, and we're going to see how we're going to do this when we get to the lab session. So over here, this is just a code snippet. Let me actually show you in the Jupyter notebook so that you get to understand well. Now, if you come here, you can actually see it over here, right? Now, you can see that I have outliers in my data set, and I want to remove these outliers, right? I want to remove these outliers. So I have this data set that I've loaded, right? If we go all the way up, right? I have this data set that I have loaded over here. Yeah, I have this insurance data set that I have loaded, and this data set contains some outliers in there, right? It contains some outliers in there. So in order for me to be able to remove these outliers, I'm going to use this interquartile range concept to actually remove that. Right? Okay, so you can see over here that I'm calculating the Q1 and then the Q3, right? So you can see that I'm using this quartile function, and then I'm calculating the Q1, which is 25, the 25%, just like earlier on we were seeing over here, right? So let me take this off. Just like earlier on we were seeing over here, right? You can see that earlier on we were seeing this 25% for the Q1, and then over here will be 75, right? It will be 75%, because if you add these, right, if you add all these three, it's actually going to be 75 over here, right? And then that's the Q3, right? So that's basically what I am doing over here, right? You can see that for Q1, right, for Q1 I'm using this 25%, and then for Q3 I'm using the 75% over here, right? And I'm using the quartile function. So we're not actually going to calculate this by hand, right? We're not going to calculate this by hand. So normally you could have done, maybe if we have a data points like so I'm just going to use any hypothetical data points like maybe 3, right? We have 3, 4, 4, 4, something like that, right? Maybe 7, 10, maybe 11, 12, 14, 16, 17, and then 18, right? So if you have data points like this, let me see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so in this case we can divide them into 4 parts. So 1 here, and then let me change this. Right, we can divide them into 4 parts. So we have 1 here, we can divide it here too, and then we can divide it here too. All right, so I can associate my Q1 here, okay, and then my Q2, this is going to be my Q3 over here too. Okay, now if I want the Q1, I could have calculated it like maybe 4 plus 4 divided by 2. I'm picking this, right, which is 4, and then 4 over there divided by 2, which is going to give me, say, 4, right? And that is my Q1. Okay, and then my Q2 is going to be this 10 plus this 11 over here, right? Which is going to be Q2 equals the 10 plus 11 divided by 2, which is also going to give me something like 10.5. okay, then if I pick my Q3, that is actually going to give me 14 plus 16 over here, which is 14 plus 16, right, divided by 2, which is going to give me something like 15. Okay, so now I can do it like this, and if I want in the interquartile range, which is IQR, right, I could have calculated it like that's Q3, which is going to be 15, minus the Q1, which is 4, right, which is going to give me 11. Okay, so this is actually going to be my interquartile range if I use manual calculation. But we're not actually going to do this because we have this function, we have the quartile function here. So I just say that's okay for the 25% of the data points are my Q1, right, that's the first 25%, and then the Q3 is going to be the 75% of my my Q3. okay, and then the interquartile range is nothing but the Q3 minus the Q1 over here, right? I can actually do that. All right, so we use this concept to actually calculate the interquartile range, the outliers in our data set. Now after that is done, what we can do, we've not come to the code yet, but I just want to give you an overview of what we use the Boxplot for, and these quartiles, because we get this Q1, we get this Q1, and then the Q3 from the the Boxplot, right? We get that one from the Boxplot, where we have the Q1 over here, and then we have the Q3 over here, right? And then we use Q3 minus Q1, right, to get the interquartile range, right, to get the interquartile range. Okay, so that's basically the concept that we are using over here. So you can see that I'm using that same concept over here to remove the outliers. Okay, so when we come to the lab session, I'm going to actually explain this step by step for you to actually understand what is going on over here. All right, so let's go back to what we were doing over here. So now I know, I mean, I have a sense of that now you know the importance of this box plot and how we actually going to use it. Let me actually show you one more example of what we are going to use this interquartile range for. When we talk about outliers, right? So if you go all the way down here, now over here you can see that I'm using Boxplot here to spot the outliers that are existing in my data set, right? So you can actually see that over here you can see that there I have my Q, right? Over here I have my maximum here, I have maximum here, I have my Q3 here, I have my Q2, I have my Q1, right, and then I have my minimum, right? But you can see that there are still some data points that are here, right? There are still some data points that you can spot here, right? You can see that there are some data points that go beyond the box plot, right? The maximum point that we know that is supposed to be, right? You can actually see them. So these are outliers in our data set. Right? These are outliers in our data set, and it's easily spotted when you use the box plot, right? It's easily spotted when you use the box plot. That's why, I mean, this box plot is quite relevant when it comes to your journey as a data scientist or machine learning engineer. You're going to be using this over and over again to spot the outliers that are existing in your data set. Okay, so over here you can actually see that I'm using them to actually see the various outliers that I have, right? So we're going to use this over and over again as we process. That's why earlier on I said that these are concepts that you're going to need. That's why I added them in the beginning in the statistics class, so that you get familiar with them as we progress to the machine learning class. Okay, so let's proceed over here and then continue from here. Now let's proceed and talk about one more concept, which is the empirical rule. Okay, now what the empirical rule is actually saying over here is that if you pick this, we will talk about normal distribution, right? If you're not familiar with this curve, right, this is just a normal distribution curve, right? This is just a normal, right, just a normal distribution, right, curve. Just a normal distribution curve, and we're going to talk more about this normal distribution curve. So just like the box plot, we're also going to see this over and over again, right? You're going to see this over and over again. Now let's now concentrate on the empirical rule, right? Before we talk more about this normal curve, let's talk about the empirical rule first. What the empirical rule is actually telling us is that if you pick if you pick your data set, right? If you pick your data set, what is actually saying that if you have let me actually draw it here for you. Let me actually draw this one from the start. So if you pick your data set, maybe you have, let's draw this normal distribution curve again from the start. Okay, so let's say this is what we have. So this is actually representing your data set. So the area below this normal distribution curve, right? So this is the normal curve. It's the normal curve over here. So the area here, right, if you pick all the area here which is covered under this normal curve, right, this is actually is equal to 100%, right? The area under is equal to 100%, or is equal to 1 if you want to pick it that way. Or if you pick it in percentage, then it's equal to 100%, or you can represent it as 1. Okay, now what is actually saying is that if you pick the area under the curve, right, which represents the total data set that you have, right, you have this you have the mean over here, right? You have the mean over here. So this is a symbol for the population mean, right? You have the mean over here, which, I mean, if you consider the mean, we have 50%, exactly 50% of your data points lying at either side of the mean, right? You have exactly 50% of your data set lying at either side of the mean. Okay, so in that case now, if you move say one standard deviation, right, so in this either right or left, so let's move to the right. So if we move one standard deviation, this is a standard deviation, right? If we move one standard deviation, so that becomes the mean plus the standard deviation, right? That's one standard deviation. That's what you can actually see over here. Okay, that's what you can see over here. Now what it's actually saying is that if you move one standard deviation, right, either left or right, so if we go to the left, then it's going to be negative, so it's going to be negative minus standard deviation. Okay, so if you move one standard deviation away from the mean, then you are capturing 68%, right? You are capturing 68% of your data set. All right, you're capturing 68% of your data set. That's what you can actually see over here. So if you move one standard deviation either to the left or to the right, then you're capturing 68% of your data sets, right? So if the 68%, then it means that we have 34% at either side of it. Okay, in the same way, if you move two standard deviation, that is not just one standard deviation, but if you move two standard deviation away from the mean, right, then I mean somewhere here, so the mean plus two standard deviation, okay, either at either side of the mean, so over here somewhere here, right? So the mean, so in this case it's going to be minus two standard deviation. So that's what you can actually see over here. Okay, so you move two standard deviation away from the mean, right? You're moving two standard deviation away from the mean, right? And in that case, you capture 95% of your data sets, right? You will be able to capture 95% of your data set. And it's actually making sense, because if you move only one standard deviation, you're capturing only this part, right? You're capturing only this part, which is only 68%. And if you move, say, two standard deviation, you're saying that you're capturing 95% of your data set. It makes sense because you are now extending it. You're capturing more of your data points, right? You're capturing more of your data points. And in the same way, if you move three standard deviation away from the mean, right? That's three standard deviation all the way here away from the mean, right? Either on the at either side of them, right? So in that case, you capture 99.7, right? You capture 99.7 of your data points, right? Which also makes sense, right? Which also makes sense. Don't forget, this one goes to infinity. This one goes to infinity. That's why you will be able to capture 99.7, but not exactly 100%, right? Not exactly 100%, because this thing doesn't even end. But if you go at say 3 standard deviation, right, away from the mean, then you know that you've captured 99.7%. Now, what is the relevance of this that I'm telling you? Now, if you consider for instance, removing outliers, right? You want to remove the outliers, but you don't want to remove relevant data, and you don't want to include noise in your data set as you proceed, right? So if, for instance, if I want to remove, if a data point is here, right? If a data point is here, right? If a data point is here, and then I see that, okay, this data point is actually an outlier. I mean, it's not what I needed. It's not part of what the data point that is necessary for me to make build a machine learning algorithm, right? The data point that lies within this one standard deviation away from the mean is enough for me, so I don't need this. Then you can set a threshold and then remove any data points that will go beyond one standard deviation away from the mean, right? You can set a threshold that, okay, now my threshold is the condition that I'm going to set over here is that any data points which is greater than one standard deviation away from the mean will be considered as an outlier, right? Will be considered as an outlier, which means I don't need that data points. Okay, now you have to be cautious, because maybe this data set will be relevant, right? Which means that you just capture very few data points. That's why this one is becoming irrelevant. So if you see the example that I showed you over here, right? The example that I showed you over here, you can actually see that you have some data points that are lying above here. So maybe I can extend the maximum to maybe this part, right, to somewhere here. I can extend the maximum to this part, so that I will be able to capture these data points too. Maybe they are relevant, right? And however, you have to be very cautious when you're doing things like that, right? And if I say that, okay, I'm going to set my threshold to be, say, any data point that is greater than, say, 2 standard deviation. Now in this case, I'm not saying 1 standard deviation. I'm increasing the data points that I'm going to use. So I want to now capture, say, 2 standard deviation away from the mean, right? It means that I'll be able to capture this data point, and it will not be a noise. It will not be irrelevant data, right? It's not going to be irrelevant data or a noise. Okay, now I'll be able to capture enough data points. That is, I'm capturing about 95% of my data points I'm going to use for building a machine learning algorithm, right? I'm not going to ignore that. And you have to also be careful, because maybe this is really a noise that you don't want to capture, right? This is really a noise that you don't want to capture, or maybe there might be another data point somewhere here, which is, that one is really a noise, but this one is not a noise. But since you increase it to say 2 standard deviation away from the mean, you have captured that one too, which is really in a noise, okay, or really irrelevant data. All right, so now if you see the threshold that we set when we're removing this outlier, right? Let me actually go here and then show you. When we're dealing with removing the outlier over here, you can actually see that I want to get rid of this. Okay, you can actually see that we set a threshold that any data points which is greater than 1.5 times the interquartile range, right? We're going to, if you subtract it from the Q1, it's going to be considered as an outlier. So we set a threshold of 1.5, right? 1.5. So it's more like 1.5 times 1.5 standard deviation away from the mean, right? 1.5 standard deviation away from the mean, either negative or positive, right? That is at either side of the normal distribution, right? So this could be the normal distribution over here. Right, so it's instead of maybe going this the mean, so instead of maybe going 1 standard deviation away from the mean, which is going to be the mean plus that, or maybe it's going to be the mean minus that, right? So in this case, I'm going to use 1.5, which is the threshold that I'm setting, right? So in that case, I'll be able to capture I'll be able to capture somewhere here, right? I'll be able to capture. So if a data point is here, then a noise is here, I'll be able to ignore it. So I'll be able to capture a significant amount of my data, right? I'll be able to capture a significant amount of my data without me losing important data points, right? And also not capturing many noise, right? Not capturing many noise, which I don't need. Okay, so we set the threshold to be, say, 1.5 instead of maybe 2 standard deviation, or maybe 1 standard deviation, which is going to be less. Or if we take, say, 3 standard deviation, it's going to be very huge, and we're going to be capturing a lot of noise over there. Okay, so you can actually get to understand, this is just one implication of the empirical rule that you can actually understand. And we're going to see this over and over again as we proceed in our machine learning class. As we build, we get a data set, and then we start doing the exploratory data analysis. You're going to see a lot of these as we progress. All right, so basically that is what you need to get to understand so far. Now in the next video, what are we going to consider is what is referred to as the correlation, right? So in the next video, we're going to talk about correlation. All right, so see you in the next video.